I'm going to be doing number 21 from chapter 6, which is a conservation of momentum problem. A 45 kg girl is standing on a 150 kg plank. The plank, originally at rest, is free to slide on a frozen lake, which is a flat, frictionless surface. The girl begins to walk along the plank at a constant velocity of 1.5 meters per second to the right relative to the plank. A, what is her velocity relative to the surface of the ice? And B, what is the velocity of the plank relative to the surface of the ice? First, we're going to illustrate what is happening in our problem, and essentially we have a girl who's walking on this plank that's on ice, and the plank on the ice is frictionless, and this side is going to be positive and this side is going to be negative. Essentially, the velocity of the girl relative to the surface of the ice is equal to the velocity of the girl relative to the plank plus the velocity of the plank relative to the ice. And in the problem, they give us that the velocity on which the girl's walking on the plank is 1.5 meters per second. We then set up a conservation of momentum equation. So we set the initial momentum of the girl on the ice plus the initial momentum of the plank on the ice equal to the final momentum of the girl on the ice and the final momentum of the plank on the ice. Because the girl and the plank are both starting at rest, we put 0 kg m over s for the initial momentums. After doing some manipulation of our equation, we can see that velocity of the plank relative to the ice is equal to negative mass of the girl times the velocity of the girl to the ice over the mass of the plank. So now that we have the velocity of the plank to the ice, we can plug that into this equation. And so when we plug that in, we can see that the velocity of the girl relative to the ice is on both sides of the equations. So we're going to have to move this portion onto the other side. And as you can see, after manipulating our equation, we found that the velocity of the girl relative to the ice is equal to 1.5 meters over seconds, which is the velocity of the girl to the plank, over 1 plus the mass of the girl over the mass of the plank. And after plugging in our values, we see that the velocity of the girl relative to the ice is 1.15 meters over seconds. In part 2 of this problem, we're finding the velocity of the plank relative to the surface of the ice. So recall that in part A, we decided that v of the girl relative to the ice is equal to 1.5 meters over seconds plus the velocity of the plank relative to the ice. And we found that the velocity of the girl relative to the ice is 1.15 meters over seconds. So we can just plug the velocity of the girl relative to the ice into this equation, and we find that the velocity of the plank relative to the ice is negative 0.35 meters over seconds. The negative just indicates that the plank's motion relative to the ice is opposite of the girl's motion relative to the surface of the ice. Thanks for watching!